Welcome back. Welcome back. I hope everyone had a great lunch.
So, ladies and gentlemen, now it is time for our keynote speech, and the topic is one that I am personally very interested in. Lately, artificial intelligence has become a household name. It is almost in every industry in the world right now. Talk about defense, technology, artificial intelligence is there, and one of those industries is certainly education. And to talk about artificial intelligence in the age of education, I would like to invite our keynote speaker, Mr. Charles Fadel, founder and chairman, Center for Curriculum Redesign. Mr. Fadel is a global education thought leader, futurist, and inventor, member of OECD AI Experts Group, co-author of Artificial Intelligence in Education, Four-Dimensional Education, and best-selling 21st Century Skills. He has worked with education systems and institutions in more than 30 countries and has spent 25 years in technology management. That's very impressive, Mr. Fadel. The floor is yours.
Thank you very much. Let's start with this then.
Beni davet ettiğiniz için teşekkür ederim.
We would like to invite you we would like to thank you for inviting us.
But sadly, this also illustrates a point that we'll get to in a moment when we talk about jobs. So thank you for inviting me. It's a pleasure to be here. This is the agenda. This is what we're going to talk about. I would like to talk to you about AI to demystify some of what you've been hearing in the past year or so, and start talking about what knowledge, what competencies we need, and of course, finish on how do we teach differently. A quick introduction about my center. Basically, we try to be ahead of the pack, think ahead so that we have time to prepare. Because as you know, public sector is relatively slow to adapt. Education is particularly slow to adapt. And so we really have to give you time to make that adjustment. And this time the adjustment is complicated. You'll see in a moment. My center works with a number of NGOs like the OECD and the IB, but also a number of high-ranking PISA jurisdictions and universities and so on. Here are the PISA jurisdictions we work with, the very high achievers. Because it's one thing to achieve highly on PISA, it's another to know what to do next. Sometimes your success becomes your box. And one of the things I appreciate about the Turkiye Maharish Foundation is that you have the latitude to innovate more than many others who already have a lot of systems in place. So that's an advantage you should build on. When I wrote 21st Century Skills, it became a moniker used worldwide. And that's great, because now every country understands the need to teach knowledge, but also skills and character and meta-learning. Wonderful. And as I started my center a bit more than a decade ago, I moved into talking even more about the character dimension, the knowledge dimension, and so on. Here we go. The full framework, I'll show you in detail in a moment. The full framework has been kindly translated by a very dear colleague, Dilek Duman, and she's translated in Turkish for some of you, and it's available also in many of your languages, meaning French and Arabic and so on. Actually, it's available in 23 languages, so you have a likelihood of finding what you want. We put great effort into developing the framework because it's very easy to talk about big words like creativity, critical thinking, curiosity, but you need to be precise in the definitions, and you have to make sure that those definitions are not overlapping. So we did a lot of analysis to prove that these 60 sub-competencies are as orthogonal as possible. They're not overlapping. That was critical. Anyone who works in computer science knows how important an ontology is. Well, that's our ontology here. The disappointing part, though, is that in spite of all of this work, when we did the survey with Brookings recently, we found that no jurisdiction, not even Singapore, not even whatever, choose your high-end jurisdiction, offers pedagogy or assessments of these competencies. And that's a problem, of course, because if it's not measured, it's not taught. If it's not taught to the teachers, it's not going to happen in the classroom. So we've been developing ways to deal with this. Now let's take a step back and let's talk about jobs in light of AI. Very briefly, because this is not an economists' conference. I want to mention one thing that is really important. Every time you see out of GPT-4 or anyone what AI is capable of doing nowadays, you'll see that people say, wow, it can pass this medical test, it can pass the SATs, it can pass legal tests. But first of all, this is highlighting the fact that a lot of our tests are about memorization, number one. And so, first of all, the tests themselves need to be changed. If it's just about memorization, I can memorize a lot out of the devices I have. It doesn't mean knowledge is not important. It means you have to dose it properly. Second, just because you can do a test doesn't mean you can do a task. There's probably a factor of 10 in complexity between a test and a task. Otherwise, it would be easy. Anyone who graduates knows exactly how to do in their job. That's not the case. I mean, we have, even in the US, lawyers who graduate without ever having written a law contract. They know the theory of law, they've never written a contract. And then the task to the job. A lawyer's job, a doctor's job is more than a single task. And there's probably another factor of 10 between that and the tasks, and another factor 10, of course, with the tests. So when you hear the hype out there saying, oh my God, all the jobs are going to disappear, keep this in mind. Now, when I spoke to you in Turkish, thanks to the translator here, this is something I have to say to our wonderful colleague translators. The problem you have is that your job is mostly a task, and that makes you more, it puts you more in danger than jobs that have multiplicities of tasks with glue in between them. But it's rare to have jobs that are focused on just one task. Even driving, you're not only driving on a flat roads, straightforward. You're driving at the Place de l'Étoile at rush hour in Paris. You know what that means. It's a mess. So let's not take this too far. However, when you see that GPT-4 can answer 75% of math questions in the case of exponentials in mathematics, and in the case of game theory, 90% of the questions, you ask yourself, okay, we need to rethink the tests, and we need to rethink exactly what the comprehension is of the students. But again, tests is not equal to task, is not equal to jobs. What we're not saying is you don't need to know anything anymore. On the contrary, we're saying you have to sophisticate your understanding. So this is basically the consequence of all this. We're not going to be in a situation where AI replaces us for quite a while, but it's like any new technology, it's an amplifier. You can decide to use the amplifier to help yourself or refuse it, and then you're left behind. I'm sure when the wheel or the car were invented, there were always people saying, you know what, I prefer to walk. Fine, it's your choice, but I'll be able to go faster, carry heavier loads over longer distances. Okay, let me take you through a brief look at the history of technology. The good thing today is that we had two panels, one talking about history, one talking about technology. I'm going to bring the two together. First of all, I've been around for a while, so I started an AI company on neural networks back in 1989. Of course, that shows you how old I am. But the benefit of it is I've been through cycles. I've seen how things progress, and they're never just a straight progression. You have this issue of punctuated equilibria. And now we've seen, in the past couple of decades, we've seen the 2010s with machine learning, and I'll explain what that is in a second, and now we've seen generative AI and large language models. But that's already starting to peak. Even if there's a GPT-5, given that Sam Altman just got fired, we'll see. even if there is one, it's not going to be massively better than GPT-4. So in all these technologies, you see a ramp up from GPT-2, not good, GPT-3 and a half, wow, GPT-4, wow, and then GPT-5, okay. So it's normal to see this kind of situation. And that's hard for technologists because everyone is wedded to the technology they have developed. So those in the 80s were wedded, married if you prefer. They were married to a type of AI called symbolic. And for them, nothing else mattered. Nothing else was going to work. They failed. The new generation now working with machine learning and neural networks, they say, oh, my algorithm will do everything. They're going to fail as well. It's going to do amazing new things, but not everything. So this is what we've seen with machine learning. We were, the game tree complexity is enormous. Look at this, 10 to the power of 535, so 10 with 535 zeros. No human mind can compute this, and so these machines can win in highly computing intensive situations. AlphaFold, how do you fold proteins? How proteins fold on themselves. Well, that's also a very complicated problem, but you can automate that now once you know the rules. So they can compute millions of protein foldings in an instant. But they're greedy. They need an enormous amount of data. Just AlphaGo to play Go, it would have taken us 6,800 years to learn as much as it did. We don't have that kind of time. They're also very brittle. They break easily. For them, these two things are a face because they recognize features of a face, but they don't understand the real world. They don't have an internal concept of the real world. So for them, these are faces. We know better. They mistake a robin and a cheetah just on the basis of very, very few pixels that you can hardly see. They confuse a stop sign with a speed limit just on basis of a few stickers. They don't have a concept of the real world, they're just recognizers. It doesn't mean you cannot do amazing things, it means it has limitations. And from there, you can see as you go into the LLM domain, how they can start to hallucinate, as was described earlier. So they're shallow. If you make them recognize a dog, they will see dogs everywhere. You see? They're recognizing dogs. Dogs everywhere. They don't see the difference. Again, dogs everywhere. That's what they do. So it depends on how you train them, how you tweak them. And so to train them and to tweak them, you have to present the data in a very nice way, very clean, whereas real life is a mess. So it has limitations. Then they're opaque. We have no idea how they actually work. This was said this morning. Yeah, we don't know how it works because you have 5,000 layers of neurons computing a face recognition. You have no idea at every single point what's happening, but that's how we recognize faces too. We don't know at every single point what's happening. It's okay, as long as it works. Remember, evolution has wired us to be functional and useful. It hasn't wired us to be super elegant. It worked. So there was a major transition that happened recently, right? Back a year ago. What we started seeing was this change from machine learning systems to large language models. And with that, although they're based on the same types of algorithms, the fact that they're trained on immense data sets rather than narrow data sets like proteins or playing Go or chess, now it means that they can, quote unquote, understand from a much broader array of things. And so, whereas the other systems were bounded, as in engineering we call them bounded problems, now the boundary is much, much, much greater. They're still bounded, but immensely greater. And second, now you can connect these LLMs together via things like LangChain and API. Forgive me, translators, I don't have words for that called it LangChain and API. Basically, technologies that allow you to connect different data sets and different algorithms and different models. All of that now can be brought together. Okay. And this is really important because it removed the single approach barrier that we had seen before. Okay, how did we get here? This is the history of it. 1895, conditional probabilities with Markov. I'm sure the poor man had no idea that he was going to create this 100 years later. No idea. In 1948, Shannon wrote this wonderful paper on theory of communication, and this is what he wrote. This is really interesting. He looked at the frequency of appearance of letters in English, one after the other. You can do this in any language. And then he continued making it more and more complex. What's the likelihood of two letters showing together, like B and ba? What's the likelihood of these two showing right next to each other? And then 3 letters, and 4 letters, and words. And that's what you end up with. Second order, third order, first order word approximation, second order word approximation. Look at the last paragraph. It's starting to resemble a real language, and he did this manually in 1948, okay? So you add 100 million times more processing power and, you know, 1 trillion words, and you come up with much better predictions. That's what happened. So these technologies were, in essence, started very, very long ago by people who had no idea where this was going to go. And in the meantime, of course, we invented the transistor. And we invented the integrated circuit. So what happened was that in 35 years, since I had, back in 89 when I had my AI company, we could compute 3 layers of neurons only. Cannot do anything with that. But with 5,000 layers, the world has changed. And we had a 100 million-fold improvement in processing power in the meantime. Makes a difference. And then you have people who say, well, it's going to be just my model. As I was saying earlier, just my algorithm will do everything. And I'm saying, no, that's not the case. You're going to have different types of algorithms all working together. But no, it's not going to come up to a single master algorithm. The same way that our brain has figured out, you don't have a single type of cortical structure, a single type of a brain area that does it all. It's really a combination of things that specialize in different domains, and that's how we're going to see emerge. So that's why all of the people who are saying, oh my God, LLMs are going to create this enormous change for everything, are wrong. They're simply saying this because they know LLMs best. That's how they spent 30 years of their career. And so for them, their baby is perfect. And I'm saying, sorry, it's beautiful, but it's not the only baby in the world. You're going to need others to get to this stage. That said, I don't want to minimize the stage we're in. This is amazing. This is an amazing moment. We have highly capable AI that's going to become even more capable because of all of these things that are all coming together. So let's not lose sight that even if they don't become general intelligence, they're highly capable. Okay, so that's the middle way. Neither are they useless, nor are they capable of being completely human. It's a middle way. Okay. So we're limited by our imagination, because when you asked a drawing cartoonist back in 1899 in France to draw things about year 2000, that's how he conceived a robot. In his imagination, all he could do was draw on the technologies that were available at the time. Mechanical engineering was the high tech of the time. So there's a mechanical contraption. There was no electronics, no small cheap motors. So you had the maids pull the thing. That was the robot. He could never have imagined Roomba. But we're a bit in that situation now. So it's perfectly normal when people say, oh my God, we cannot imagine what's going to happen. Yeah, we can't. Okay, let's live with it. That's normal in the life of technology. There are plenty of unintended consequences that we cannot imagine. Let's be adaptable like we've always been as a species. And so that's why this is really the pattern. We expect things to change in a linear way, but that's not how they change. Think of the internet, for example, or iPhone or whatever. It starts very invisibly, it ramps up, and it starts saturating. Even if this whole curve is compressed in time, it's still an S-curve. So the problem is this is moving a lot, still moving a lot faster than we can adapt, right? And so public policy is at the bottom, the slowest to adapt, and technology moves the fastest, and we have to run where the ball will be. That's what you do in football. That's normal operating procedure. But that's a tough thing to do. So if you look at the Bloom taxonomy, for example, that many of you as educators know about, well, in Bloom's taxonomy, you have software or applications that can deal with pretty much the whole stack. But let's be a little bit more precise, okay? Because everybody talks about these things in general terms. So let's play a little game. In your opinion, can an AI determine connections? So those who think it can, raise your hand. Can an AI determine connections? Raise your hand. Only a few? Okay. Can AI spot analogies? Okay. Can it predict outcomes? Okay. Can it handle exceptions? Can it deal with abstraction? No? Some? Yeah? Let's say, can it generalize reasonably? Sometimes. Can it be self-aware? Not quite. But you see, it's really always a question of sort of. I saw you discuss, some of you said sometimes. That's the nuance that you have to pay attention to. It's not, oh yeah, I can do these things. No, it's in what situation, what context, with what capabilities. Is it an image that you have to translate into words, et cetera, et cetera, et cetera. It's not that straightforward. And same thing for the affective domain. Right? It can do a lot of things. It cannot internalize emotions, but it can do a lot of things. Have you watched the Netflix series called Humans with an inverted A? It was a Swedish series that became translated in English called Humans. You have, some of you have. Well, in that series, remember how the little girl loves the robot better than her mother because the robot is infinitely patient? You know, we're parents and we get home and we have our little kid who wants to read the same story for the 50,000th time. And we're a bit tired and we're cranky. The robot, super patient. It is tireless. We are human, right? And of course, there's a psychomotor domain. We're more comfortable with that for some reason. We have giant trucks doing mining, and we're only afraid of the truck running on your foot, but you're not afraid of the truck replacing you. Although, if you think about it, the giant truck has replaced tens of thousands of people digging and shoveling. So somehow we have adapted. We are going to continue adapting. But there's a key durable consequence of all of this that I would like to highlight to you. This. It has no agency of its own. It has no purpose of its own. No meaning, exactly. So we are still driving, AI responds. That's great. But here's a question for you. I'm curious. Who among you thinks that AI already has an identity? Raise your hand if you think it has an identity. Timid hands, timid hands. Well, the timid hands are right. It has already 3 layers of identity. The first layer is how you train it, what data set. The data set colors what it says. So if you train it on a medical data set, it's going to answer medical questions. So it already has that level of identity. Second, You have the algorithm that you use. You can use different algorithms, and respond different ways. That's an identity. It's like different people thinking in different ways. Third layer, and that's the crazy layer, agents. You can put an interface and have it converse to you in the way you want, a bit like Siri or some of these boxes. Yeah, so you can start talking to you with an angry voice, with a happy voice, with a whatever voice you want. And people now are going to be developing tons and tons of agents to put as interfaces. It's a bit like TikTok for LLMs. I don't know how great that's going to be. Okay, so what we have, of course, is this repeat of the situation we saw with the Industrial Revolution. Technology zoomed ahead during the Industrial Revolution. Now, with the digital revolution, technology is zooming ahead of education. So what did we do to adapt? We invented mass schooling. Okay, and now what do we have to do to adapt? We have to mass sophisticate. We have to rethink what we teach, and we have to rethink how we teach at both the teacher level and at the student level. So what we advocate for is a need for versatility. In all honesty, no one can tell you what's going to happen in a decade from now. Okay, we have some ideas, we try to be reasonable, but no one can tell really. So the same way you take an insurance policy, we think that the right insurance policy is to be multifaceted, be able to be a knife or a can opener or whatever. Depending on what life throws at you, you can be a poet or a painter or a physicist or a physician. Who knows? Okay? So we give you all the tools, and then you can refine the tools later as you need them. Which means we want a Renaissance sort of person, someone who's broad and deep, not one or the other. Someone capable of expertise and transfer, not one or the other. And I want to use this because this morning, one of the professors mentioned the need to teach everybody AI. And here's the nuance. It's not teach everyone AI as an algorithmic sort of thing. It's teach everyone about AI's capabilities. And that's very different because it's not the pathway of expertise, it's the pathway of transfer. It's what's called expert amateurism. I can teach you a concept without having to teach you the algorithmic side, the complex side of the concept. It's that simple. I'm going to show you an example. All right. Let's talk about knowledge. Like every domain in learning sciences, it's a mess. Everybody comes up with their own theory. Our role as a center is to figure out what is actually correct and not have an or mindset. Professor XYZ says it's my theory that's correct versus Professor XYZ says, no, it's mine. Here we say, look, there's truth in all of you, and we have to assemble it the right way. It's an and proposition. And so what is really coming out of all of this analysis is that we still have declarative knowledge, facts. We still need conceptual knowledge, concepts. We still need to learn the procedures, and we still need to learn the epistemics at the bottom, meaning how do you think like a mathematician? How do you think like a historian? It doesn't mean you want to become a mathematician. You want to understand their thought processes. So here's what core concepts are about. They're drivers. Everybody learned at school what an exponential is with a certain algebraic formulation. But we had a pandemic, and everybody reacted terribly around the world, very poorly, very slowly. Why? Because they don't understand the concept. The concept behind an exponential is deceiving, then explosive. But when have you ever had a math teacher who explained that to you? Right? They only explain the algebraic formulation. They don't explain what it means. And even if they explain what it means, you didn't keep it in your guts. It didn't resonate in you deeply. So next time you see an exponential, like global warming, you say, oh my God, I really need to react fast because I know the system is gaining momentum. And once it gains momentum, it's much harder to stop. And not by a factor of 10, it could be by a factor of 100 or 1,000. And that's the situation in which we are with global warming. And we just keep on wasting time. It's not linear, it's exponential. And our politics, our corporations, either do not understand or refuse to accept the need to act urgently. So again, we would have saved ourselves trillions of dollars with the pandemic had we stopped it really early. Same for all of you who are confronted to Zika or Ebola or SARS or whatever. So, the leaves are the essential content. That's what we typically teach. We need to teach the roots, the concepts. But we also need to modernize the disciplines themselves. Why do we teach so much trigonometry and so little statistics and probabilities? Why don't we teach world literature? Why don't we teach world history? As one of the professors was saying this morning, give people a better understanding of the planet they're on. Why don't we teach during performing arts not just theater, but debate and comedy and even improv? You know, be fast on your feet. That's what the world demands nowadays. That you'd be really, really, quick to react. Well, improv allows you to do that. It trains you to do that. How about teaching modern disciplines, like technology and engineering? Why not teach civil and mechanical and electrical, etc. engineering? I was an electrical engineer. I didn't want to be a computer scientist. At best, you get the option of learning computer science in high school. So what? There are plenty of other engineering disciplines I could have been interested in. And by the way, there's also biotech and clean tech and nanotech. Why does it have to be, again, only computer science? I understand, super important for everybody. But how about the rest? Well, because we have used up all the time for the old disciplines. So there's no time left. So we have to go back and cut out, which is extremely hard to do, as you all know. And then, so we keep talking about STEM, but it's really STM at best, small t. No social, we don't teach social sciences, and yet we need to understand ourselves and others. We don't teach entrepreneurship, and yet entrepreneurship is the job of the future. So we don't do the right things in what we teach. Of course, interdisciplinarity, like environmental literacy and digital literacy and so on. Digital literacy, right? It doesn't mean that everyone has to know how to code a machine learning system. It means you have to understand how to use it. It's different. And you have to learn via projects. Why? Right? We have all done projects, they've all stuck in our memory because they were engaging, motivating. And the real world is about projects. Life is about projects, and yet we don't do enough of them. And we can even line up the projects to the UN Sustainable Development Goals. We can line it up to the World Economic Forum Deep Shift Technologies. So what we do with the projects have an interesting purpose. Okay. So what competencies? You're familiar with them already, creativity, critical thinking, etc., but also the aspect of character, curiosity, resilience, etc. When COVID happened, everybody just jumped and said, oh my God, the students have to be resilient. You don't teach that in 2 months. It's a journey that they're on from kindergarten onward. And that's not taught. And so people react and, sorry, it's too late now. You need to prepare ahead of time. It's like taking vitamins when you're pregnant. You know, you try to prevent issues. You don't want to show up after the fact. And then meta-learning. This is at a premium. If you agree with me that an AI is not self-conscious, it cannot reflect on itself very easily, well, that's our advantage, isn't it? Because we supposedly can. That should be taught. And that's, by the way, the highest return on your investment in education, by far. It's very cheap to implement. It gives you the highest return from a student perspective. And you can line up these competencies with the various disciplines. Not every discipline is as good as the others at developing them. The point here is to develop them deliberately, comprehensively, systematically, and demonstrably. Every teacher will say that, oh yeah, I teach critical thinking here and there. The point is to do it systematically and do it well. That's not easy. Now, above and beyond that, what you add to the framework is student personalization. The framework are the goals. We need to personalize for the students. We've always known that forever, right? However, we have distilled what it means. Remember how we talked about does a computer have identity, agency, and purpose? Well, there you go. This is the differentiation. Even if you had a technology that did absolutely everything for you, you still would want some sense of purpose for the student, some agency for the student, some motivation for the student. And that's where it comes together. So the agency changes over time. The younger student has less agency, the older student has more agency. That's normal. And your purpose has to incorporate all of these things together, right? What you love, that would be great. I love what I do, so I'm not working, really. Since I started doing this, I don't feel like I'm working. This is a passion. Is it what the world needs? Can I be paid for it, and can I be good at it? If you only tell the kid one of these four things or two of these four things is not enough, they really need all four. Sorry, cameras, but I'm going to come down in the audience. So how do we teach with AI? All right, it's really augmenting our learning. It's how we teach better. It's hand in hand with the technology. So adaptive learning already had this promise because you can self-pace, right? So some people will learn more slowly than others, and you can self-pace their education. And AI can give you extra gains because they're a tutor. You're familiar with the 2 sigma problem. Now that can be your tutor. So you help the teacher, you help the student. You can minimize the overall time, and you can maximize the time to mastery for individual students. That's the promise. It's getting into reach now. And that opens a range of possibilities. What's the percentage, what's the ratio between what the teacher does and what the student does and everything in between, right? 100% teacher, 100% student, and you have all these modalities in between that we're going to see. So it really opens amazing horizons. We're going to be exploring a lot of this in the decade to come. It's fascinating. But we're limited in our imagination again. This was also done in 1899, and this is how they saw e-learning. Note that there was also a mechanical device that somehow generated current on the other side, which actually is not completely wrong. And here we are, my center, we have generated for the first time 1 million synthetic students. And the beauty of synthetic students is that you can run experiments on them without harming them, right? So my daughter does this in healthcare. They have, let's say, 50 real patients, but they need 50,000 or 500,000 to run their analytics. And so they just create synthetic patients. So here we've created Learnoids, synthetic students, on which we can refine our AI-based analytics. Plenty of fun. So to conclude, you see a lot of disciplines go from being purely descriptive or qualitative to becoming more and more analytical. Think of biology. A few decades ago, I mean, a century ago, if you wanted to see the difference between species, you looked at beaks, you looked at feathers, etc. Now you do a DNA test. It's become a lot more analytical. What you're seeing here is the emergence of education engineering. Not engineering education, education engineering. The same way that you have civil, mechanical, electrical engineering, this is the birth of education engineering, where you become much more precise, much more specific, much more science-centric, engineering-centric in your processes to understand how to teach better. Okay? And with that, yes, a little bit of publicity. This and more will be available in January, a lot more. There's so many details. For example, for every single one of these competencies, which subcomponent is going to be resistant to AI, is going to be augmented by AI, is going to be harmed by AI. That's the analysis we're doing. And that's it. Thank you very much.